Good day everyone, I am Althea Baldosa and I'm going to discuss about chi-square test for independence. Another kind of chi-square test is the chi-square test for independence. The chi-square test for independence evaluates the relationship between two variables. It is a non-parametric test that is performed on categorical data that is measured on a nominal or an ordinal scale. Let's have this example. 500 elementary school boys and girls are asked which is their favorite color, blue, green, or pink, and below are the results. By using alpha 0.05, we conclude that there is a relationship between gender and favorite color. So here's our table. On the bottom, you can see that we have column totals 120, 180, and 200. And on the right, we have the row totals 300 and 200. And we had a total sample of 500 people. So we can use this information to calculate our chi-square. And we're going to do a hypothesis test using the 7 steps. First step is to state our null and alternative hypothesis. Our null hypothesis is for the population of elementary school students, gender and favorite color are not related. And our alternative hypothesis is for the population of elementary school students, gender and favorite color are related. Alpha is always equal to 0.05. And to calculate degrees of freedom, now we're going to multiply rows minus 1 and column minus 1. So we have 2 rows and 3 columns. 2 minus 1 is equals to 1. 3 minus 1 is equals to 2. 1 times 2 is equals to 2. So this analysis will use 2 degrees of freedom, and that's how we find our decision rule. And we're gonna go to our chi-square table. And using alpha 0.05 and 2 degrees of freedom, we find a critical value of 5.99147. So our decision rule is if the calculated chi-square is greater than 5.99, we are going to end up rejecting the null hypothesis. So let's calculate our chi-square now. And we're gonna use the same equation to calculate it. Except now we're going to be a little bit more complicated to find the expected frequency. And this is how we're going to do it. We're going to multiply frequencies of columns times frequencies of rows, divided by total number of subjects to get the expected frequency for each cell. For example, let's say we wanted to find how many boys are expected to have chosen blue as their favorite color. We take the column total for blue, which is 120, and multiply it by the row total for boys, which is 300. And then we divide it by the total number of subjects, which is 500. And we find out that in this sample, we would have expected 72 boys to choose blue as their favorite color, and continue that to get the expected values for all 6 cells. So let's gonna remove the top, and we have the observed values, and the next to them is in parentheses we have the expected values. Take all the observed values and subtract the expected values. Then square that and divide it by the expected values to get those 6 different fractions. When we add those all together, we find a chi-square of 276.389. So our result is, because our chi-square was greater than 5.99, it was 276.389. We will reject the null hypothesis. That is to say that in the population, there is a relationship between gender and favorite color. Using the chi-square test, the test for independence.